Hello there and welcome to this CSWatch J276 video where we are going to be looking at TCP IP, what are the different protocols that use TCP IP, what are layers and how the layers of TCP IP can be used. So, TCP IP is split into two sections. It's two protocols used at the same time. TCP IP is the protocol for how data is sent between networks, and two protocols is made up of. First of all is TCP, Transmission Control Protocol, and that sets the rules for how devices connect to the network, how all that side of things work, and then IP is responsible for the packet switching. Bringing them together to create TCP IP is how the information gets sent across the network. There are other protocols that use TCP IP as a basis. So for example, we've got HTTP, HTTPS, and they're used by web browsers to access websites and to communicate with web servers. We've got FTP, which, as you can probably tell, is used to access, move, and edit files between devices on a network. So if you're going to be uploading something onto a server or downloading something, you'd be using FTP. You've then got POP3, which is used to retrieve emails from a mail server. The server keeps hold of the email until you download it, at which point, once you've downloaded it onto your local machine, it gets deleted. And then you've also got IMAP, which again is used to retrieve emails from a server, but the main difference between that and POP3 is that where POP3 deletes it, on IMAP you download a copy. Most web-based email clients, so for example Hotmail, Mail.com, use IMAP. And then SMTP is used to send emails and also to transfer emails between one server to the other. So we've got all those different protocols which build upon TCP IP. If you take the idea of TCP IP apart, so taking away the TCP part, which is for how to connect to the network, and the IP part, which is responsible for packet switching, none of those technologies would work. We've then got the idea of layers. Layers are a group of protocols which have similar functions. So we can see here, for example, we've got the four network protocols which are divided into layers. And we can see here that the layer 4, the top layer, is the application layer, and that is what you see when you're using something. So it turns the data into websites and applications, so you can see things. The transport layer controls the data flow, splitting the data into packets, checking packets are sent and received, making sure all the packets are being sent over correctly. You've got layer 2, which is the network layer, which directs the packets, connects the networks, used by routers to make sure everything gets sent over. And then finally, the data link layer, which is passing the data over the actual physical network cables, over the physical wireless connectivity, electrical signals. So all those together, you need to use them. So when you are downloading something from Steam, you're using all four layers. Each layer can see what's above it and below it. So layer 3 can see what is going on to layer 4 and 2, but it can't do anything at all with layer 1. If we're thinking about the protocols we saw on the previous slide, application protocols would include FTP, SMTP, and HTTP. The transport layer, of course, would be TCP. The network layer, that's where you get your IP coming into it. And then the data link layer, you'd get the protocol for whatever connectivity you are using. So, TCP IP is essential for data transfer. Other protocols rely on TCP IP to function. If TCP IP was taken away, a lot of the internet would start to break. Layers are self-contained and they work together to perform some sort of goal. Advantages of using layers include breaking network communication into manageable pieces, which then if you're creating something which uses those layers, they can developers can focus on one set at a time. And having a set of rules for the layers, each layer makes companies make sure whatever they are making is universal. So then different brands will work with each other. So then you don't have to worry about the whole PC Mac, because if you buy something for Mac, it might not be suitable for PC. When we're looking and dealing with using layers and TCP IP, that problem is negated. So I hope you've enjoyed having a look at TCP IP and feel much better about it, and I shall see you in another video. See you later.